Okay, these are the homework problems that we already went over in class on Friday. So we'll just hurry through. Okay, if you remember the lesson from yesterday where we looked at the orange juice concentrate, where you had to have 1 can of concentrate and 3 cans of water, and we had a ratio table that showed us for every can of concentrate we added 3 cans of water. So there's what the ratio would look like outside of the ratio table, and it is proportional to the 2 cans of juice and 6 cans of water, just like in the ratio table. And that means it's also proportional to 3 cans of juice and 9 cans of water, which is also proportional to, can you guess what the next ratio might be? It would be 4 cans of juice or 12 cans. Get ready for the lesson. Leon spent $2 to make 10 prints from his digital camera. Later, he went back to the same store and spent $6 to make 30 prints. Express the relationship between the total cost and number of prints he made for each situation as a rate in fraction form. $2 for 10 prints, $6 for 30 prints. Compare the relationship between the numerator of each rate. The numerator in the second rate is 3 times the numerator in the first rate. So $6 is 3 times $2. Compare the relationship between the denominator of each rate. The denominator in the second rate is 3 times the numerator in the first rate. So 30 prints is 3 times 10 prints. Are the rates equivalent? The rates are equivalent since they have the same unit price, $1 for 5 prints. In the situation in getting ready for the lesson, there are 2 related quantities, the number of prints and the cost of the prints. Notice that both quantities change, but in the same way. As the number of prints triple, the cost also triples. By comparing these quantities as rates in simplest form, you can see that the relationship between the 2 quantities stay the same. 10 prints for $2 equals 5 prints for $1. And 30 prints for $6 is also 5 prints for $1. Proportional, 2 quantities that have a constant ratio or rate. In the example above, the cost for making prints is proportional to the number of prints because each quantity has a constant rate of $1 for 5 prints. Proportion. In words, proportion is an equation stating that 2 ratios or rates are equivalent. Examples, 2/5 equals 6/15. You can multiply the numerator and the denominator by 3 and you get 6/15. So in the previous example, 10 prints for $2 or 30 prints for $6, those are proportional. There are different ways to determine if the relationship between 2 quantities is proportional. One way is by examining unit rates. Examples, use unit rates. Determine if the quantities in each pair of rates are proportional. Explain your reasoning and express each proportional relationship as a proportion. Number 1, 20 miles in 5 hours and 45 miles in 9 hours. Do you see any pattern between these 2 ratios? Write each rate as a fraction, then find its unit rate. So we have 20 miles in 5 hours. And we can divide 5 hours by 5 to get 1 hour, which is our unit rate. And then we have to divide the numerator by 5 as well. So we get 4 miles per hour. Looking at 45 miles in 9 hours, we have to divide 9 hours by 9 to get the unit rate of 1 hour, and 45 miles by 9, because whatever we do to the denominator, we have to do to the numerator to get 5 miles per hour. Since the rates do not have the same unit rate, they are not equivalent. So the number of miles is not proportional to the number of hours. Number 2, 3 t-shirts for $21 and 5 t-shirts for $35. Do you see any patterns? $21 for 3 t-shirts. We need to divide 3 t-shirts by 3 to get our unit price of one t-shirt. Then we need to divide $21 by 3 to get $7. Now if we look at $35 for 5 t-shirts, we need to divide 5 t-shirts by 5 to get our unit, and then $35 by 5 to find out the cost per unit. Since the rates have the same unit rate, they are equivalent. The cost is proportional to the number of t-shirts. The two ratios in a proportion are equal, so they share the same unit rate. A proportion is a statement that two ratios are equal. It can be written as two equivalent fractions, 3/5 equals 9/15, with a colon, 3 to 5 equals 9 to 15, or with words, 3 is to 5 as 9 is to 15. Number 3, reading. Elisa read the first 60 pages of a book in 3 days. She read the last 90 pages in 6 days. Are these reading rates proportional? Explain your reasoning. So we have 60 pages that she read in 3 days, and where you need to find the unit. So we divide 3 days by 3 to get 1 day, and then we divide 60 by 3 to get 20 pages per day. Look at 90 pages in 6 days. We need to divide 6 days by 6 to get the unit of days, and then 90 pages divided by 6 to get 15 pages per day. Since the rates do not have the same unit rate, they are not equivalent. So the number of pages read is not proportional to the number of days. Check your progress. Jewelry. Marsha made 10 bracelets for 5 friends. Jen made 22 bracelets for 4 friends. Are the rates proportional? Explain. 10 bracelets for 5 friends. Divide 5 friends by 5 to find 1 friend. Divide 10 bracelets by 5 to get 2 bracelets per friend. 12 bracelets for 4 friends. Divide 4 friends by 4 to get 1 friend, and 12 bracelets by 4 to get 3 bracelets per friend. Since the rates do not have the same unit rate, they are not equivalent. So the number of bracelets is not proportional to the number of friends. Fundraising. Club A raised $168 by washing 42 cars. Club B raised $152 by washing 38 cars. Are the fundraising rates proportional? Explain your reasoning. $168 for 42 cars. Divide 42 cars by 42 to get 1 car. And divide 168 by 42 to get $4 per car. $152 for 38 cars. We'll divide the 38 cars by 38 to get the 1 car unit. And then $152 by 38 cars to get the $4 per car. Since the rates have the same unit rate, they are equivalent. Both fundraising clubs raised $4 for every car they washed. Examples: unit rates. Determine if the quantities in each pair of rates are proportional. Explain your reasoning and express each proportional relationship as a proportion. Number 4. 3 free throws made out of 7 attempts, and 9 free throws made out of 14 attempts. So we're going to set up a ratio, 3 free throws over 7 attempts. and another one, 9 free throws over 14 attempts. If we multiply 7 times 2, we get 14, but we have to multiply 3 times 3 to get 9 free throws. The numerators and denominators are multiplied by different numbers, so the fractions are not equivalent. The number of free throws made are not proportional to the number of attempts. Number 5, 6 DVDs for $90 and 3 DVDs for $45. So we have 6 DVDs for $90 and 3 DVDs for $45. If we divide 90 by 2, we get 45, and if we divide 6 DVDs by 2, we get 3 DVDs. The numerators and denominators are divided by the same numbers, so the fractions are equivalent. The number of DVDs is proportional to the cost. Check your progress. 5 packs of baseball cards for $15, 10 packs of baseball cards for $30. 5 packs for $15, 10 packs for $30. Multiply $15 times 2 to get $30, and 5 packs times 2 to get 10 packs. The numerators and denominators are multiplied by the same numbers, so the fractions are equivalent. The cost of the packs of baseball cards are proportional. D, 12 girls out of 16 students, or 4 girls out of 8 students. So we put 12 girls over 16 students and 4 girls over 8 students. If we divide 16 students by 2, we get 8. And if we divide 12 girls by 3, we get 4. The numerators and denominators are divided by different numbers, so the fractions are not equivalent. The number of girls and number of students are not proportional. Additional examples. Determine if the quantities in each pair of rates are proportional. Explain your reasoning and express each proportional relationship as a proportion. 20 rolls for $5 or 48 rolls for $12. So we have $5 for 20 rolls, and that comes out to 25 cents per roll because we divided 20 rolls by 20 to get 1, which is our unit, and $5 divided by 20 to get 25 cents. So if we have $12 for 48 rolls, we'll divide 48 rolls by 48 to get 1 roll, and we'll divide 12 by 48 to get 25 cents. Since the rates have the same unit rate, they are equivalent. The cost per roll is the same, so they are proportional. Number 2, 42 people on 7 teams, 64 people on 8 teams. So we have 42 people on 7 teams, and we'll simplify that to how many people on 1 team. So if we divide 7 teams by 7, we get 1 team. And if we divide 42 people by 7, we get 6 people per team. So now we're going to do the same with 64 people on 8 teams. And we will divide 8 teams by 8 to get 1. And 64 people divided by 8 to get 8 people. Since the rates do not have the same unit rate, they are not equivalent. Number of people on teams is not proportional. There are 8 people per team here and 6 here. Number 3, food. You can buy 3 medium pizzas at the pizza place for $18 or 5 medium pizzas for $30. Are these selling rates proportional? Explain your reasoning. So $18 for 3 pizzas, and if we divide 3 pizzas by 3, we get 1 pizza. Divide the price, $18 divided by 3, it's $6 per pizza. And then we have $30 for 5 pizzas, and that comes out to $6 per pizza as well. So since the rates have the same unit rate, they are equivalent. Pizzas are $6 each, so the selling rates are proportional. Number 4, 5 laps swum in 8 minutes, 11 laps swum in 16 minutes. 5 laps in 8 minutes, 11 laps in 16 minutes. If we multiply 8 times 2, we get 16, but we have to multiply 5 times 2.2 to get 11. So the numerators and denominators are multiplied by different numbers, so the fractions are not equivalent. The number of laps are not equivalent to the number of minutes. Number 5, 8 corrals with 56 horses and 4 corrals with 28 horses. So we have 8 corrals and 56 horses, 4 corrals and 28 horses. If we divide 56 by 2, we get 28. If we divide 8 by 2, we get 4. The numerators and denominators are divided by the same numbers, so the fractions are equivalent. The number of horses are proportional to the number of corrals. And this is your homework that is due for this lesson, page 331 to 333, 2 through 16 even, 27 through 37 all.